I recently had one of my students asking me about dependency injection. It came up in an interview and he was curious about it. I typically don't use nor do I recommend dependency injection. However, it is common enough that it's important to understand how it works and why you might not want to use it or why you might want to use it. So that's what this video is about. So let's start off with what is dependency injection? Dependency injection, it basically has two parts. There's a lot to it, but I'm going to break it down into two parts. Number one, it is a strategy pattern. So we're defining some abstract class or some interface that represents the abstraction and then, or the core strategy. And then we're going to create concrete strategies from that. So at its basic, it is a strategy pattern. And it's using a concept known as inversion of control, but I'm not going to get into that for this. So mechanically, we're talking about a strategy pattern. The second part of it is an object known as a dependency injector. This is sometimes called an IOC container or inversion of control container. The Microsoft version of this injects via constructors. There are other versions of dependency injection that will inject dependencies, true dependencies, based on either arguments to a method or as values to properties. But the Microsoft version is only on constructors, and then we're forced to basically hold on to those in either fields or properties. So that's the Microsoft implementation, and that's what I'm going to really dive into today. So what are the problems with dependency injection? Chad, why don't you recommend dependency injection? Excellent question. I'm glad you asked. Let me pull up some example code here and let's talk through a couple of things. So the first problem that I typically run into, and this problem is not universal, it doesn't happen all the time, probably 20 or 30% of the time. That is, we can have some interface that only ends up having a single concrete implementation. So a strategy with only one concrete strategy. Let's take a look at this, for example. If I look at the, let me move my face. If I look at the uses of iadmin repo, we'll notice that it's held onto as a field. It's passed into constructor. So there's DI, field, constructor, there's DI. Here's inheritance. So we have one implementation and then we have the DI scoping itself. So this interface only has one implementation. Why do I have it? Why have I complicated my design and my code for an interface when I only ever have one concrete implementation? The whole idea of strategy patterns, you have multiple implementations. What are you doing? You should at least have a different one for testing, right? So if you don't have a different one, why did you do this? What was the point of that? It makes no sense whatsoever. So that's my first problem. Now, that's not a universal problem. Not everybody does that. If you're using good testing, you are creating multiple implementations, in which case, congratulations, you are absolutely using DI correctly rather than just using it rote because it's best practice. It's not best practice. It's a stupid practice if you only have one implementation of the interface. Don't do that. Number two, the next problem that we run into is bloated object graphs. What am I talking about here? So let's look back down at the references and let's take a look at one of these controllers. We'll notice that the controller in this case is getting an iadmin repo, an iCurrentUser, an iSession service, a DB context. So there's a few objects coming in. I'm gonna drag my face back down. There's a few objects coming in that's a part of this object. Each of these objects may then have their own constructors that take additional dependencies, and so on and so forth. What ends up happening is this controller object, which is created at the beginning of the web request, is going to be injected with all of its objects, which are then injected with all of their objects, which are injected with all of their objects. And that whole object graph lives through the life of the web request. It's not necessarily a bad thing. I mean, if we're going to create these objects anyways, then it's not like we're superfluously creating objects on the graph that just need to be torn down. But the problem starts to come into when some of these objects can be longer lived and reused across contexts where they don't make sense. And in particular, I'm talking about something like, oh, I don't know, a DB context, for example. So Entity Framework is a very powerful data access framework. I really enjoy some of the functionality it gives us, particularly around testing. However, the problem can come into if we're doing queries and the DB context is holding on to those objects in memory because it needs to manage state. And maybe we needed to correctly, right? So we're querying objects, we're updating them, or we're persisting them. And we forget to maybe clean the cache out or reset the DB context. If it gets used in another unit of work, now we're creating bloat in our entity graphs. And this is one special case, but you can apply this to more general cases, which are objects which are used across units of work will now have bloat unless you remember to do it. Well, if you have to remember to clean up your objects every single time through the different methods that you're using, the different units of work, I would argue you're not obeying unit of work. What you're doing is you're making some other controller have to remember the unit of work, and that's an anti-pattern. So ultimately, this creates very large object graphs that, if nothing else, we have to keep in our heads and understand what's going on. So that's problem two. Again, it doesn't win the day. Certainly, it's not the end of the world, but that is a potential problem. Number three, the next problem that I have a concern with is scoping. So scoping is generally done globally. That means if I make this a singleton or I make it scoped, which is usually for a web request, or if I make it transient, which usually means for every time it's requested, we create a new instance of it. If I do that, I'm defining that scope globally. And so that means if I have two different use cases or two different units of work, depending on your verbiage that you like, what it means is those can't have different scoping options. I have to pick a scope that is universal across that. That doesn't always apply in the real world. There are times when I need different scoping levels in different use cases. Same object, different scope. Maybe in one unit of work, I actually need to persist that across several different pieces of functionality. Whereas another one, I want to make sure I'm getting a new instance every time because I absolutely need to make sure I'm not sharing the functionality. It could be the same functionality, but the caching rules or the lifetime scoping rules, the calculations that it holds on to and uses later on, those could vary use case to use case. This one, the number three, is probably the weakest of the four arguments I've got against it, but it does come up from time to time. Number four, this one to me feels like the strongest argument and the one that I really have a hard time with, is that it requires us to use composition. Now you might say, well, Chad, composition is generally better than inheritance. Okay, I'm not going to argue that side of it. In general, composition will help us be more flexible in how we solve future problems than inheritance. Inheritance is a relationship. It means we have an abstract base class or an interface, which, by the way, we do. But in this case, we're actually using composition to allow some of the changes that need to happen to make more sense. We can create better abstractions. We can create better decoupling between objects, let those concerns be independent. That's absolutely usually a good thing. When you need inheritance, you need inheritance. But a lot of times that people use inheritance, yeah, they could probably get away with composition. You know what else they could get away with? Dependency or association. And that's actually a much more preferred way to do things than composition. One of the reasons I have a hard time with the Microsoft dependency injector is that it requires composition. Some of the other dependency injectors that Microsoft rejected actually do dependency injection, true dependency injection, where a method argument could then be passed in rather than it being passed in a constructor. That means the method itself would only need the dependency for the lifetime of its method rather than being in the lifetime of the object or the class itself. You could also do that with properties, although properties still get us into a compositional problem. But dependency and association is actually a much better problem, or a much better way to solve a lot of the problems than even composition. So if we're talking about the 80-20 rule, yeah, 80% of the time composition is better than inheritance, but 80% of the time dependency is better than even composition. So dependency, there's a couple ways we typically see that. One is as an argument coming into the method. The other is we just new up the object inside the method, right? So we just create a new instance or call a factory method or whatever it is you want to do. So those are the main reasons why I tend to stay away from dependency injection in general, particularly Microsoft's implementation of it. It creates designs that are bloated and don't make sense, and people just follow it because, well, it's what you're supposed to do, even though it makes the code a lot harder to read, maintain, and understand, especially when you only have a single concrete implementation for an interface. Why? Why, for the love of God, why are you doing that? So what are our alternatives? Excellent question. I'm glad you asked. So there are 23 Gang of Four design patterns, and there are several other things that have come around since then. Now, not every one of the 23 is going to be applicable for inheritance. We need something that is specifically for inheritance, something like strategy pattern, command pattern, bridge pattern, decorator pattern, et cetera, factory pattern, abstract factory pattern. So it's not going to be all of the 23, but there are a couple of patterns that absolutely make sense, because what we really want is inversion of control. And inversion control is absolutely important to make sure that we keep our dependencies pointed in the right direction. I'm talking, of course, about Clean Architecture from Robert C. Martin, Uncle Bob. You have read it, right? If you haven't read it, please make sure you go read Clean Architecture. He talks about this in great detail. All our dependencies should point inwards on the graph. You could invert that and make it a horizontal or a vertical stacked graph. And then in that case, everything should point down. No dependencies should ever point up. Flow of control can go down and up, but your dependencies only ever point down. Or looking at it as concentric circles, flow of control can go in and out of the circle, but dependencies always point inside. So we absolutely want to make sure we're using inversion of control by making sure our dependencies point inside the graph where it makes sense. So we still need inversion of control. What are we to do if not use dependency injection? Well, how about just a strategy pattern? Or one of my favorite patterns, factory pattern. So these are some great ways. I often will use bridge patterns where it makes sense. So you can use some of these basic patterns. Strategy and factory are probably your two best friends. There are certainly times to use like a command pattern, bridge pattern, maybe a decorator pattern. Those tend to be rarely used. But there's a couple of patterns there that you can use. In addition, if you're not really wanting to use a dependency injection, but you still want some IOC container because you want to register everything, maybe in a central place and have a common place to go, I would recommend looking at the service locator pattern. I like it a lot better than the dependency injection pattern because now you don't have a single object where everything is registered for all your dependencies. You still have a single point of failure. You still have what you might consider to be a God object because now that service locator has to know about, or at least register and then give back all the dependencies. But I find it to be a much more flexible design pattern than dependency injection. So that's another idea. And then finally, I would ask, do you really need inversion of control in this case? There's a lot of times that people will create interfaces like this. You'll create an interface or an abstract base class, and you didn't really need it in the first place. You only have one concrete implementation. If that's the case, don't create the complexity. Don't create the inheritance in the first place. If you only have for iAdmin repo, if there's only mediator admin repo, don't create iAdmin repo. There's no point of it. How do you know if there's a point to it? So this gets me to my recommendations. Recommendation number one, use test-driven development. That is the number one way you're going to know whether you actually need an interface or not. Your tests are going to help you decide if you want to mock something out or not. Now, when I say test-driven development, I do not mean unit tests. So please don't get those confused. Unit tests and test-driven development, if you overlay those and look at the Venn diagram, there's a very thin overlap, and that thin overlap is you should use a unit testing framework for both. Outside of that, unit testing and test-driven development look almost nothing alike, and if you think they do, you don't understand test-driven development at all. The idea of test-driven development is we want to change the way we think about units. Units are not classes or methods. Units are units of functionality. They come from user stories and they come from features. Our test-driven development tests should be as functional and system tests as we can possibly do. You absolutely need to mock out dependencies where they make sense, but a lot of cases they don't make sense to mock out all the time. So be very, very careful. If you're not really familiar with the difference between unit testing and test-driven development, I would recommend reading Kent Beck's book to get started, Test-Driven Development. After that, you need to read Michael C. Feathers, you need to read Robert C. Martin, and you need to read Martin Fowler. Those authors together, when you read all of their works and you start figuring out what they're saying and reading between the lines, you'll realize that they are saying unit tests is not the way to go. We need to have automated tests, but we need to do that in a test-driven development approach that supports refactoring. The problem with traditional unit tests is it creates a very tight coupling to the design of your code, meaning you're never going to refactor your code. That's a problem. Unit testing is not the way to go, but you should be using test-driven development. If you use TDD correctly, you're going to find out when you need an interface or an abstract class because your tests are going to tell you something about the code that says, hey, I need to use this in a different way for this particular circumstance. That will drive you to inversion of control. And if you don't have that driven from tests, you don't know that you need an IOC container, period. That's number one. Number two, use dependency over composition or inheritance. Use dependency and use a strategy or facade pattern where it makes sense. You can use other patterns as well, but we absolutely want to use dependency. We still need inversion of control, but make sure you're using one of those patterns that rely on inheritance. Recommendation number three, use dependency injection where it makes sense. If you're using dependency injection, and maybe not everything, right? This is probably too many for a pretty small app like this one. This is too many interfaces and too many concrete types. But for a small app, if you got a handful of them and you actually have multiple implementations, one for your web app and one for your tests, congratulations, you're using DI correctly. Do that. Use DI where it makes sense. I'm not saying never use dependency injection. I'm saying if you're going to use it, make sure it makes sense. So use dependency injection where it absolutely makes sense, but make sure you're using it correctly. And finally, my recommendation number 4 is when you want to get away from DI, you want to translate DI into another pattern. What are we to do there? So let's take a simple example. Let's say, for example, iConfiguration. So iConfiguration is one of those objects that's going to be injected as a part of dependency injection by the Microsoft DI container. But let's say we don't want to do that. We want to use configuration in some other way where we're not going to have an object created by dependency injection. We still need the configuration. There's a few different ways to do that, but probably the easiest way is to basically inside your configuration here when we're initializing the dependency injection is initialize some object that uses a different pattern with that configuration object. We'll have it here. We can register it. It might be a singleton pattern. It might be a factory method pattern where we're registering what the instances might look like. There's a few different ways to do that, and you're going to need to figure out what works in your particular situation. But you can basically go and say my configuration factory dot set configuration, pass configuration. And now I have that available for my configuration factory later on if I want to use it. Or maybe it's the config instance. So the config class, I might say instance dot set configuration to configuration. Something along those lines. So I can still use those patterns. What I need to do is I need to translate the DI framing back into the pattern that I want. And I do that through the traditional dependency injection code. So that's basically it. Hopefully that makes sense to you. There's a lot here. If you're going to use dependency injection, definitely do some research. Take a look and see what's going on with it. Learn it deeply. You need to understand dependency injection well if you're going to use it well. Don't just use it because that's what everybody else is doing. That's a bad reason to do anything in software development. Make sure you understand DI. Make sure you understand the ins and outs of it, what it can do, what it can't do. Use it where it makes sense. Avoid it where it doesn't make sense. And ultimately, keep bringing awesome to the people.